Hi, grade 9s. I'm going to take a few minutes here to go through the practice problems that I gave you for our properties of angles and circles. Remember, the answer key is on the very last page of these questions, so if you need to just double check your answer, do that. Don't waste your time here. Also, if you have a certain question about a specific question here, skip ahead to that part. Don't feel like you have to watch the whole video, although for some of you it might be helpful. All right, we'll jump right in here to question 3. So it says, in each circle, identify an inscribed angle and the central angle subtended by the same arc. So we're looking for an inscribed angle and a central angle subtended by the same arc. So the first thing that we need to do is just find the arc that we're looking at. So for A, the arc that's going to be most helpful is from D to E, right? If you look at the other ones, there really aren't any angles coming off of it. So make sure, and it might even be helpful for you to highlight it. So from arc DE, it looks like angle F here would be inscribed. So you could just label it with an I. And it looks like this angle here at O would be a central angle. For B, it's a little bit trickier, but we're going to use this arc here, arc PQ. And right here will be our central angle, and right here will be our inscribed angle. For C, we're going to use arc MN, and it looks like, again, at O is our central, and there's actually 2 inscribed. So this up here is an inscribed, and this over here is also an inscribed angle. So remember, we're going from the point on our arc, either to another point on the circle or to the center for our central angle. Same thing over here with B. There's your central angle. There's your inscribed angle. For number 4, point O is the center of each circle. Determine each value of x. So we're just trying to find the missing degrees. Well, it looks like for A that we're using arc BC, and they gave us a central angle of 130 degrees. X is an inscribed angle. Remember, the inscribed angle is always half of the central angle. So I would go 130 divided by 2. That would give me, let me do this math in my head, 65 degrees. So angle X would be 65 degrees. For B, the arc that we're looking at is from D to F, which is a semicircle. So here through O is my central angle, which is 180 degrees. My inscribed angle over here where X is going to be half of that, which is 90 degrees. So in this case, X is going to be 90 degrees. And that's our semicircle rule. For C, it looks like we're using arc JK. And it looks to me like this 40-degree angle over here is an inscribed angle. It's going from J and K to the edge of the circle, 40 degrees. X over here is also an inscribed angle. And we know that inscribed angles subtended by the same arc are equal. So in this case, X is equal to that other angle, which is 40 degrees. They're both inscribed. And for our last one, D, we're looking at arc NR. And it looks like they gave us an inscribed angle over here, 29 degrees. Here at O, or angle X, we're trying to find the central. Remember, the central angle is twice as big, so we have to do the opposite of what we did over here with A. So if the inscribed angle is 29, I need to go 29 times 2, which is 58 degrees. So X would be 58 degrees. For question 5, point O is the center of each circle. Label each vertex, determine each value of y and z. which circle properties did you use? So label each vertex just means like doing something like over here is A and B and C and D. Label each vertex, determine each value of y and z, and then which circle properties did you use? All right, so for the first one, we're going to use arc A, B here. Angle y is a central angle. Angle z is an inscribed angle. And they gave us an inscribed angle over here, which was 70 degrees. So we know that our inscribed angles will be equal because they're both coming off arc AB. So angle Z will be equal to 70 degrees as the other inscribed angle. Angle Y will be twice as big, so 140 degrees. And I know sometimes students have to try to memorize, well, which one's bigger, the central or the inscribed, and they memorize that. I say, just look at it. Which angle looks bigger? The central angle looks way, way bigger. And that's because it's twice as big. So you shouldn't have to memorize that. You just have to memorize that it's twice as big. All right, for B, let's label our vertices. I have a low battery, so hopefully I can make it through the rest of these. So I did A, B, C, D. Let's do E over here, F here, and G. And you can use whatever letters you want. I'm going to use arc E, F. And remember, this is our central angle, which is 180 degrees in a semicircle. So to find Z, Z is going to be, if I look at this over here, the other half of my straight line over here is also 180 degrees. So to find Z, I'll need to go 180 minus the 50 degrees that they told us to get the leftover. So Z is 130 degrees. Y, well, Y is, I'm just going to erase this here. Y is this bottom angle in this triangle. And they've labeled our radii for us. So if we know that these two sides are equal because they are radii, that means it's an isosceles triangle. So this angle down here and this angle down here have to be equal. And I know that Z is 130. So remember, all the angles in a triangle add to 180 degrees. So for Y, if I take 180 for the interior angles of a triangle, and I subtract angle Z, which I know is 130, I get 50 degrees. And that 50 has to be split evenly between angle Y and this other angle over here. So I have to divide 50 by 2, which leaves me with 25 degrees. Now, what if I wanted to get Y first? Could I have done these backwards? Because in the way that I needed it, or the way I did it, I needed Z to find Y. Could I do it backwards and find Y first and then find Z? Yeah, sure. You could use this isosceles triangle to find these missing angles here. And then remember that this whole angle here together is 90 degrees. So then you could find the difference, 90 minus this angle, to find Y. And then you could find Y, or use Y, to find Z. Both ways would work. And that's kind of what I mean when I say that there's many ways to do a lot of these problems. All right, let's look at C. So C is kind of weird. I'm going to start with red. Let's find Y. Let's do Z first because that's nicer on our brain. So if I'm labeling my points, E, F, G, there's H, I, J, and K. So I'm going to use arc HI to start. And I see here an inscribed angle of 42 degrees. Z, angle Z, is also an inscribed angle of 42 degrees. So using our inscribed angles, Z equals 42 degrees. Now, y is kind of awkward here. Notice there are no central angles. There are no lines connecting to the center of this circle. So we can't use our central angle property. Well, what about this? What if I erase what I was using for angle X? And what if I look at this arc instead? Instead of using HI, what if I use JK? Well, now I have an inscribed angle off JK of 27 degrees. And look at this. Y is also an inscribed angle off of JK. So y is 27 degrees using our inscribed angles property. Number 6, point O is the center of each circle. Label each vertex, determine each value of x and y. Which circle properties did you use? All right, so for A, I'll label A, B, C. And I notice a few things right off the bat here. So if I'm looking at arc AC, that's a semicircle, which means that this here is a straight line, or 180 degrees. And it also means that this angle over here is 90. I don't know if that's going to be helpful or not, but it's something to keep in mind. Something else I've noticed is that there's a couple radii. So from the center out to the edge, there's a radii there, there's a radii there, and a radius there. Together they are radii. So those three sides are all equal. Okay, if that's the case then, that means we have some isosceles triangles. So that means that this angle here is 40. And remember, if this whole angle here was 90, that means that this part over here has to be 50. I hope that makes sense. Together they make 90. Aha! And using our isosceles triangle properties, angle y over here, angle y over here is going to be the same size as this angle over here. So angle y is 50 degrees. Okay, so if y here is 50, that means that we can add up this angle, and angle x to get 180. So if we find the difference, so for x, if I go 180 minus 50, I am left with 80 degrees for angle x. For B, this one, let's take a look here. Some things that I'm noticing, again, right off the bat. Sorry, let's label our vertices, D, E, F, G. If I am looking at arc DG, I'm noticing that it's also a semicircle. There's my straight line. So that means that I have a couple 90-degree angles. I'm just going to draw those in. 90 and 90. Okay. I'm trying to find angle y, which is this angle here, and I'm trying to find angle x, which is this angle here. The easiest way that I can think of to solve this one is to look at this set of intersecting lines here. And this goes back, I think it's grade 7, and I actually haven't reviewed it yet with you guys, so if you get this, that's awesome. When you have intersecting lines, it creates some different relationships. And one of the relationships is what we call vertical pairs. So when I have this intersecting line, the angles on opposite sides are going to be congruent or equal. So if I can find this angle here, it will tell me what y is because they're the same. And then up here and down here are the same as well. But that's not really as helpful. So this is 25 degrees here. This is 90. I can find this missing side that I'll do in green, which will then tell me what y is. So if I go 180 minus the 90 minus the 25, that gives me 65 degrees. And if this green angle is 65 degrees, that means that y is also 65 degrees. And if I know that y is 65, I can find x by doing the same subtraction, which actually ends up being just 25 degrees. There you go. That one's kind of weird, but not too bad once you understand what's going on. Last couple ones here. Whoops. Whoa. All right, rectangle PQRS is inscribed in a circle with radius 7 centimeters. The length of the rectangle is 12 centimeters. Sketch a diagram. Okay, this sounds complicated, but it's actually the same problem that we did in our notes. So if I sketch a circle, that is a horrible circle. Let me try to do a better circle. That's slightly better. And then we have rectangle PQRS inscribed in it. So I'm just going to do my best here. There we go. PQRS. It doesn't really matter how you label it. Radius is 7 centimeters, so we could draw a radius if we wanted to. That's 7. The length is 12. Cool. So this is the one that I solved by turning it into a nice right triangle like this. Remember, this side here is also 7. And we're trying to find this missing side here. So it's really not too bad. I'm just going to sketch out my triangle to find the width. So there's my 90. 7 plus 7 gives me 14 on the hypotenuse, and then I have 12. So to find it, I would just go square root of 14 squared minus 12 squared. I'll call it side B. And then when I plug that into my calculator, I would go square root of 14 squared minus 12 squared. Gives me 7.2. It's 211, but they want it to the nearest tenth, so that would be 7.2 centimeters. Not nearly as bad as it sounds. And then last set of questions here. Point O as the center. Label each vertex. So A, B, C. Determine each value of X and Y. Which circle properties does each question illustrate? Okay, well, the first thing I notice with A is if I use arc BC, I have a central angle here, and I'm looking for an inscribed angle. So that means that angle X is going to be half of 80. So angle X is 40 degrees. The other thing I notice is that I'll do them in green. This side here and this side here are equal. So if I look at this as a triangle, it's an isosceles triangle. And if I erase that, because I drew over what I'm looking for, angle Y is just this little part here, not the whole angle, if that makes sense. So if I have an isosceles triangle, that means that our small angles over here and here are going to be equal. So that means that Y is also 40 degrees. If I'm looking at B, I see, let me just label my vertices, A, B, C, D, E, F, G. If I look at either arc DF or DF this way, we get some straight lines through the middle there. And that means that we have some inscribed angles on the other sides that are 90 degrees. 90 and 90. So let's take a look at Y first. If I know in this triangle that this angle is 50, this angle is 90, I can find my leftover one. So for Y, I'll go 180 minus 90 minus 50, which gives me 40 degrees. So Y is 40. X, if we look at the other side of the triangle, this one over here, they have told us that this side and this side are equal. They've given us the markers that show they're equal. So that means it's an isosceles triangle. So this angle here and this angle here will be equal. So if I go for X, 180 minus 90 leaves me with 90 degrees. And those 90 degrees have to be split evenly between x and this other missing angle. So 90 divided by 2 gives me 45 degrees for angle x. And our last one, DEFG, so I'll label this HIJ. I'm going to start with angle Y in the middle. So remember, when we have a central circle like this, the angles have to add up to 360 degrees. So to find the missing angle at Y, 360 minus 116 minus 128 will leave me with, bear with me 1 second, 360 minus 116 minus 128. Y is 116 degrees. That one's not too bad. For angle X, I'm looking for this whole angle over here. Now, there's a couple ways that we could do that. You could find this little part here, because these are isosceles triangles, and you could find this little part here, because this is also an isosceles triangle, and add them together. You could do that absolutely. An easier way would be to look at, at least I think it's easier, look at arc HI. We have a central angle of 116 degrees, and we have an inscribed angle, which is angle X. Both of these sections put together. So to find angle X, all I would have to do is simply go 360. Sorry, not 360. What am I doing? 116 divided by 2. Remember, your central angle is twice as big as your inscribed, or your inscribed is half the size of your central, which gives me 58 degrees. If you did that one the other way, you should get the exact same answer. So it really doesn't matter. That's it for this week's practice. If you have any other issues or questions, or if it still doesn't make sense, please feel free, shoot me an email. I am here to help. Thanks, grade 9s.